Hey everyone, welcome back to the Molecular Mind with AS. In today's video, we'll explore a very important concept, effect of a catalyst on a reversible reaction. We'll also discuss an example of phosphorus pentachloride decomposition and see what happens when pressure, concentration, or temperature change. So, let's dive in. In a reversible reaction, both forward and backward reactions occur at the same time. At dynamic equilibrium, the rate of the forward reaction equals the rate of the backward reaction. It means that the amounts of reactants and products remain constant, not because the reactions have stopped, but because they are happening at the same speed. Now, let's talk about the catalyst. A catalyst is a substance that increases the speed of a reaction without being used up itself. In a reversible reaction, a catalyst increases the rate of both the forward and backward reactions equally. It helps the system reach equilibrium faster, but it does not change the position of equilibrium. In short, catalyst, faster equilibrium, but same equilibrium position. Let's take an example, the reversible reaction of phosphorus pentachloride, PCl₅. Equation PCl₅, G, choose PCl₃, G, plus Cl2, G. In this reaction, 1 mole of gaseous reactant, PCl₅, produces 2 moles of gaseous products, PCl3 and Cl2. This reaction is endothermic, which means it absorbs heat in the forward direction. Now, let's predict what happens when different conditions are changed. Q1. What happens if the gas mixture is compressed? When we compress the gas, pressure increases. The system will try to reduce that pressure by shifting toward the side with fewer gas molecules. On the left side, we have 1 molecule, PCl₅. On the right side, we have 2 molecules, PCl3 plus Cl2. So, the equilibrium will shift to the left, forming more PCl₅. Q2. What happens if we add Cl2 gas to the mixture? Adding Cl2 means increasing the concentration of a product. The system will try to reduce this change by moving toward the reactant side. So again, the equilibrium shifts to the left, forming more PCl₅. Q3. What happens if the temperature is increased? The forward reaction is endothermic, so increasing temperature favors the endothermic direction. That is, the forward reaction. So, the equilibrium shifts to the right, producing more PCl3 and Cl2. Now let's recall the main concept of today's lesson. A catalyst increases the rate of both forward and backward reactions equally, helps the reaction reach equilibrium faster, does not change the equilibrium position or the amounts of reactants and products at equilibrium. So, the catalyst only changes the speed, not the final balance. Let's summarize everything we learned. Reversible reactions can reach equilibrium where both reactions occur at the same rate. Catalyst speeds up both directions equally. It does not shift the equilibrium position. Pressure, temperature, and concentration can shift equilibrium, but catalyst never does. And that's all for today. Now you know how a catalyst affects a reversible reaction. It's like a shortcut that helps the reaction reach balance faster. If you found this video helpful, give it a thumbs up, subscribe to the Molecular Mind with AS, and comment below. What other example of a reversible reaction do you know? See you in the next video where molecules meet your mind.